I'm Gary Gruber, and I'm very happy to be back here again. I try to vary every time I'm on. I try to vary the program a little bit, but unfortunately the strategies are the same. They don't change, so I want to stick with the pretty much the same examples that I've been using, and sometimes I'll vary them, but one of the most important things, I always like to start out the program this way. You want to get involved with the text. You don't want to act passively on the text. You want to actively is what you want to act as. And the way to do that is to get involved with the problem. So while I'm reading through a problem, I try to extract something from the problem that leads me to the next step of the problem, and from that point I go on to the next step maybe, and then finally I get the answer. I mean, this is exactly what Einstein and the great journalists do. They look at a problem, and instead of fixating on the answer, in fact, Einstein actually was disappointed when he got the answer to a question. Because the process is over. It's like listening to a piece of music. You hear the music, and you get absorbed in the music, and once it's over, it's over. I mean, you might have a memory of it, but you don't get that same feeling when you were listening to it. So my point is that try to get involved. I mean, I can look at a problem and get passionately involved, even though I might have seen it thousands, literally thousands of times. As a matter of fact, just to give you an example of that, I was once doing a thing for PBS, and it was called Thinking Your Way to Better SAT Scores, a while ago. And I was doing this in front of a lot of school districts. I mean, it was a televised thing. And I'm doing a problem that I've seen thousands of times, and I stopped, and I said, wait a minute. I've looked at this problem thousands of times. Why am I getting so excited? This is what teachers need to do and what students need to do. And I thought, because there's something classical of nature, there's a classical feeling you get in the problem, the feeling like you want to relive that situation. You want to see that beauty of that solution. Maybe we should start out, with an example. Let's look at one of the first examples. By the way, I want to mention something to you. You can always reach me on my website up here, www.drgarygruber.com, and I usually try to answer every question that I get when you send me a letter on the website. In fact, if you want to personally send me a letter, it'll maybe be quicker if I get it that way. Send it to drgarygruber @yahoo.com. So it's Dr. Gary Gruber @yahoo.com. That's a personal email that you can always send me. I will look at that immediately. So, but you can always write me on my website and take a look at the website too. There's loads of articles and information on that. And by the way, for the new SAT, when it comes out in 2016, I'll certainly have updates on what's going on there. April 16th is the time that everything will be disclosed. And I know, of course, some of the information already on that. But if you're taking the exam in 2016, you should start getting aware. I'll keep you posted with things like that, though. Anyway. Let's go to the first example. What percent of 5 is 20? Now, many people will say, oh, do I put the is over the of? Do I put the of? What do I do with this thing? You don't want to do problems. If I had to do problems where I had to memorize the situation, or I had to figure out, well, do I do this or that? I wouldn't want to do it. I wouldn't be interested in doing any of this work if that happened. But if I see something in that problem, well, by the way, I want to tell you before we do this, 65% of California students got the wrong answer. They probably thought, well, 5 over 20, we'll put 5 over 20. And notice something very interesting. On a test, they're going to always have what's called distractors, which are the wrong answers. They're not going to be random choices. They're going to be choices that if somebody got the wrong answer, they're going to get penalized. I mean, they're going to try to lure somebody maybe into the wrong answer. And that's why I proposed to the College Board many, many years ago. We decided not to do this, or they decided not to do this, a weighted answer test. I said, to be fair, give the kid credit. You want to develop the kid's self-esteem. You want to get this so that, they see something like, what's the average rate of a car going uphill at 30 miles an hour and downhill at 40, the same distance? And what is that rate? And somebody chooses 45 because they average 30 at 40. You don't penalize the person. You say, wait a minute, you know what average was, but you didn't know that the average rate is not the same as the average of the rates. Subtle point, but then you can go on with a problem that way. But so this is what, you want to get into the strategy mode. So let's look at how this can be done. Now, this is a powerful strategy, by the way. It should be Guide 214 now. I update the books every year. Here's the strategy. Every time I see a what, I put an X. An unknown. Every time I see a percent, I put slash 100, over 100. Every time I see an of, I put a times. Every time I see an is, I put an equals. Let's see what happens. The what becomes X, the percent becomes slash over 100, the of becomes times, the 5 is a 5, of course, the is becomes equals 20. This becomes X. Look how I'm translating this now. X over 100 times 5 is equal to 20. Okay? And then I use another strategy. I know this is going to be a little difficult to see because we're doing slide by slide. But if you multiply from that equation, both sides by 100, you want to get rid of the fractions. You get X times 5 is 20 times 100 is equal to 2,000. Divide both sides by 5, you get X equals to 100. This is a very powerful strategy, this translating from verbal to math. So you see an is, an equals, an of, a times. Okay? So what I'm trying to say to you is that by using strategies, let's see if I can get you another strategy. Yeah, let's take a look at this one. What is the value of X in the diagram below? I look at that and I say, oh my, what do I do with this situation? When you were in geometry, the first thing the teacher should say to you is that when they're proving, let's say, two sides of a triangle are equal, the base angles are equal. I want to prove the base angles are equal. Two sides of a triangle are equal, let's prove the base angles are equal. And what does the teacher do? Drops a perpendicular line down. The teacher should say, and some of them may do that. I'm not condemning every teacher. The reason why we drop a perpendicular line down is because every time we draw a line in a diagram, especially if it's symmetrical, we may get something equal out of it or something else out of it that we didn't see before. It's a natural phenomenon. So if we have a diagram, I'm going to be tempted to draw a line. So the powerful geometry and drawings and geometries draw extra lines to get more information out of the problem. So what will we draw here? We draw that line. Why not? And let's see what we get. We draw that line, we get the 4 there, we get the 3, the 5, and we have now a 3, 4, 5 triangle. And the answer then is 5. So you see how easy that is? I can show you problems on the SAT where I don't think I have the problem here, but where I think 12 people out of 1,000,000 people got the problem right. Some phenomenal number like that. I have it in my latest book, the 2014 book. And just a small number like that got the problem right. Had they used a strategy like this, plus another strategy that I had, they would have gotten it right. And it was a very difficult problem. Let's let me see about another example. Oh, that's, I had long meetings with the College Board, and on what to do with a new test and what to, what's going, kind of my ideas on what should be going on. And one of the things that I brought up with them was I was concerned with the use of calculators on the test, which in fact they're changing now on the 2016 test. And I said, many questions should not be used with a calculator. You should isolate the questions that need to be used with a calculator, or maybe better with a calculator, and ones that aren't. So here's a good example of one that should not be used with a calculator. 2/3 times 3/4 times 4/5 times 5/6 times 6/7. Now here's a very important situation that you should be very aware of. You see the 2/3, the 3/4. Try to get, I can't emphasize this more, try to get actively interested and involved in the problem. What do you see in the problem that's curious? Curiosity is such an important thing. I don't know why kids lose it, but they lose it when they get older. And when they're adults, some of them don't even have curiosity. I look at this and I say, isn't this interesting? There's a 3 in the numerator, a 3 in the denominator, a 4 in the numerator, a 4 in the denominator. It goes on like this. Why not just cancel like this, those numbers? And what do I get? I'm left with 2/7. So I can do that without a calculator. Now, of course, if you have something like 4/77ths as an answer, if you get that, you're going to want to use a calculator for that. However, if I got 4/25ths, I might not need to use a calculator, because 4/25ths, you multiply the 25 by 4 and the 4 by 4, and you get 1,600. So I could have gotten, let's say, 16% that way. Now, let's, I want to go on also to the verbal things to this, but maybe we'll do, let me do one more. Oh, I didn't even see, I didn't realize I had this thing. Let's do this question. Points A, B, and C. I wasn't even thinking of doing this, but it's a challenge question. Points A, B, and C and X do not lie on the same line. Point X is 5 units from A and 3 units from B. How many other points are on the same plane? That's a very difficult question. Let's score the points, making sure that A, B, and X do not lie on the same line. I'll do this fairly rapidly just to give you. Now, if you consider all possibilities, this is what happens. But maybe we should skip this one, because this is a little more difficult to do on the thing. I thought there may have been. Let's do another example using the strategy that I had before. A four-sided figure ABC contains interior right angle C. AB equals 12, BC equals 3, and CD equals 4. Okay? And AD equals 13. What is the area? And you say, how do I find the area of that thing? What the heck do I do with that? Well, the first thing is to draw a line, right? The key strategy is draw lines. Okay? I'll draw that line. And notice what I get when I draw that line. I get a 3, 4, 5 triangle. And if you didn't know it's 3, 4, 5, you could figure out 3 squared plus 4 squared is 5 squared, the Pythagorean theorem. And that's one thing I want to tell you, is that basic skills is very important. Let me give you an example of what I mean by a basic skill. A basic skill is to know that 2 to the 3rd times 2 to the 4th is 2 to the 6th. 2 to the 7th, right? You add the exponent. So 2 to the 3rd times 2 to the 4th is 2 to the 7th. By adding the exponents. The same way as an odd number, you have to know what that is. That's a basic skill. A strategy is how do you use that? Drawing lines is a strategy. So you want to make sure you know the basic skills cold before you get into the exam. And that's why I even have in my books a math refresher thing that completely gets you to see the math, or a verbal. Here's an example of a verbal basic skill. Uh, you have to know prefixes and roots. That DE means away from. So now if you want to use that in a strategy and you see the word delude, and you say, I don't know what that word means. Figure it out by saying, well, DE means away from, so that has to have a negative connotation. It means away from something. You know, somebody once I was working with somebody on the phone. Sometimes I would work with people on the phone for this thing. They pay me, of course, but the kid said to me, I don't know what the meaning of inexplicable is. And I thought, oh my God, I forgot what that meant. I forgot what inexplicable meant. This is very embarrassing. What am I going to tell the kid? I mean, I don't want to go to his parents saying, he didn't even know what that word meant. I thought, wait a minute, I'll use my own strategy. In means not or away from. Let's say that's what it means. I mean, it could also mean toward, but let's say it means away from. But now what about the explicable? So I use this my own strategy. Associate words with other words. Extricable, extra, not too extra, but doesn't make a word. So I said, oh, okay, wait a minute, try to figure out something that does make a word. Extract, not to extract. That makes a word. And I said to them, it means you can't extract it, you can't separate them. They're inseparable. So not inextricable means not extractable. Okay, you can't get it out. Well, that was the answer. I use my own strategy by doing that. And I'm saying this is very interesting because in a state of panic, in the same way that I was I was training teachers, and there must have been 1,000 teachers in the audience. This happened to be a math audience. And I said to them, I can solve, it was the end of the day, and I said, I can solve any problem that you give me on, let's say, the SAT or whatever, as long as a genius can solve it in less than an hour. Or less than an hour, less than a minute. So somebody, I was going to get up, somebody from the college board, I told you it was from the college board, guy got up and said, okay, wise guy, I think you use those words. Let's see if you can solve this. And the problem was something like this: coffee and espresso are mixed in so many pounds, and this, and this. Those mixture problems are brain rackers. And I thought, well, I'm going to just rush into the problem, but no, I'm a strategist. Let me use my own strategies, And I thought, wait a minute, what am I going to do with that? I'm going to extract something from the problem that I already know. Coffee and espresso and mix to get 50 pounds. C plus E equals 50. I wrote that down and I said, all I need now, because I knew the basic skills, all I need is another equation to solve that system, and I was able to figure it out. In other words, that launched me to think of the other equation, which I was able to do, and then I figured it out. And I told the audience that. I said, first I was panicky, like a student would be, but I used my own strategies. And the guy was impressed, of course, that, wow, he did use his own strategies. Everybody has that in them. This is what I can't emphasize more. We all have that ability. It's that we don't use it, or we're headstrong and we want to use what we've been taught already. Let's do this particular problem. So we get 3 and 4 are 5. 3 squared plus 4 squared is 5. So we get 5 is that. Now the big question is, can you solve that problem? Can you find the area of that? You have to figure out, well, what is the area of this thing? And the area is going to be, let's see if we, of the first triangle, the 3, 4, 5, is going to be 3 times 4 over 2. Okay, right? And the other one is going to be 5 times 12 over 2. Right? I'm just adding what the areas of the triangle are. So the total area then becomes 36. And that's how to do that problem. Let's go on with here's actually a very simple problem, and I may as well explain this because a lot of people got this wrong, and yet it was so simple. Suppose you have a question like this. A rectangle is inscribed in a quarter circle as shown below. The radius of the circle is 5. Find the diagonal of the rectangle as shown in the diagram. You say, what? How do you get that rectangle? Remember drawing lines? And that's 5. All you need to do is draw that line. And what is that line? That's the radius of the circle. And that's it. And you got the answer. Let's go to the previous one. It's just the radius of the circle. But let's see if we can get to a verbal question. While I'm on this thing, let's just do one more of this. This is the math question that so many students got the wrong answer. So let's do this one. Since I have it down there, I forgot even I had it down on this one. That's the question. So you have this kind of diagram, and you want to find out which is true. I'll give you just like a minute to think about this. And I'll answer some of the questions. And, in fact, why don't I answer one of the questions in the meantime? Chelsea says, for the ACT, which math is more prominent, geometry or algebra? They're about the same. In the, they're both. The algebra may be a little more, but that can vary. It's not a I mean, they're both important. So I would, in fact, the strategies are identical pretty much to the SAT strategies on the ACT. I wouldn't go like learn more of algebra than geometry. And you see, that's not how they make up these exams. They don't do it based on we're going to put more algebra and we're going to put more geometry. And they're based on we're going to put questions that we can really test to see whether the kids really have a knowledge of how to solve these questions. And that's how they field test these questions. I hope I answered that question. Well, to Tatiana, and I want to go back to this problem if you don't mind. Tatiana says, how do I get a 36 on the ACT? You're talking about a perfect score, actually, right? That's a great question. You need to certainly know all the basic skills code. Okay. Now you learn the strategies, and then if you take one of my books, I have the beautiful thing I think about the books that I have that I mean, besides loads of stuff that you can reference, like a short SAT test, a short ACT test, the most important questions, that type of thing. But when you take a practice test, practice is important. Take a practice test. The answers are key to basic skills and strategies. And when you get an answer wrong, you should see, how did you do that question? And did you use the right strategy? Did you use the correct basic skills? And the more you see the pattern of like, oh yeah, I should have used this strategy. I should have drawn this line, not that line. Or I should have done this. I should have used obstreperous is a big sounding word. I should have thought about obstreperous that way, and ob is against also. So, magnanimous is a big sounding word. So, think of that. And all the strategies are in the book, and also in the practice test, the answers are key to them and explained through the strategies. So that's how I would get a 36. Now, the other way to get a 36 on the ACT is you can, in my ACT book, for instance, take the short ACT exam and learn all those strategies on that short test. And then see what when the 2016 comes out, I'll have a similar thing, but that will be geared to the 2016 exam. So, but you're taking the 2000. I mean, you're not going to take the 2016 exam right now. Does that answer your question? If not, Tatiana, write me send me that. And I want to get to this question, but what is it? 2 says, what is a good way to accurately answer reading questions when there is a long passage and limited time? Great question. Great question. The way to answer reading questions, and I tell everybody, is to, especially if it's a long passage, is to get involved with the passage. Okay, so if it starts out with, it says, half a thousand years ago, think to yourself, don't just read on, think, what is half a thousand years ago? That's 2,000 minus 5, minus 500, that's 1,500, we're in the 1500s. We're in the Middle Ages. That makes you want to go to the rest of the question. It says underline things in the passage. For instance, if the passage says, Einstein doesn't believe that nature plays dice with the universe, underline that. I guarantee you there will be a question based on that. What does that mean? Because as you're reading it, if you're going to say, I wonder what that means, believe me, the test maker is going to ask you about that. So get involved with the passage, underline things. I have a whole bunch of strategies, I believe 9 strategies, reading strategies. The most important ones are, of course, the underlining and the getting involved with the passage. In fact, I have a section in the books where I describe how do you read a passage, how do you get involved with a passage. And that's how to do something like that. So even though you have a limited amount of time, there is a way to get involved enough and a way to understand what's going on in the passage that you can almost anticipate the questions. And while we're on that subject, I want to tell you something very, very important. Do not, I cannot emphasize this more, not only my research, the College Board's research shows this, do not look at the questions before you read the passage. Many people say, oh, I'm going to look at the questions, and that sounds good. That means I'm going to see the questions first and see what they're going to ask. No, that starts destroying involvement in the passage. Believe me, when you read the passage, you will be able to, if you're astute enough and you concentrate enough, you'll be able to almost anticipate all the questions, and that's how to do well on that section. In other words, as I'm reading the passage, I should be thinking, oh, there could be a question on this, there could be a question on that. You'll almost anticipate the questions. You don't need to read them first. The other problem of reading the questions first is that you start fixating on whether you memorized that. So when you're reading the passage, you disinvolve yourself from the passage and try to fixate on what you remembered in those questions. So I wanted to just mention that to you. Let me go on to this problem. So here's an example. By the way, if I'm doing something on here and you have a question saying, Gary, enough of the math or enough of this, go on to something else. Let's do this. I mean, I always want to be direct. I mean, I got to tell you this, that there was one time when I was fascinated in tests. In fact, since I got a 90 IQ on an IQ test, I felt like I was stupid, and I had to do well on tests. My father got hold of a test, an IQ test, and said, why don't you practice on it? And I looked at the test and I thought, isn't this interesting? Yeah, I could have answered the question this way and that way. So out of a very negative thing came a positive thing where I became the leading authority on standardized tests. But the thing is that what you want to get, this interest of getting involved is very, very critical. But I got to tell you one thing. When I was a student, a teacher would give exams, and I noticed on the exam, the question could have been made a little more interesting or something like that. So I went to a teacher once and I said, you could have put wording like this and it would have made the question a little more challenging and it would have been more interesting. So the teacher looks at me and says, what do you think? You know so much? She gives me a D. My father had to go up to school and they changed the grade. They changed it to a B or a C. I forgot. But don't do something like that. Don't antagonize, the authority, so the teacher. But anyway, I'll tell you, the reason why I got ahead was because I had an active approach and a passionate interest in this kind of thing. And kids lose that. I can't tell you how many kids lose that when from 3 years old, 4 years old, and then it goes down. Okay, so let's do this problem because I really would like to show you the whereas only a handful got this right. I think it was 12 or something like that. So the idea is to find out what which of these is true. So you want to find a relationship between this. Now, how do I find that relationship? Okay, let's go to the next slide. Let's draw that line. See that line that I drew? Now notice what I get by drawing that bottom line here. I now get the fact that I get two triangles here. I get that x plus y plus b plus c plus z in the big triangle is equal to 180, and a plus b plus c is 180 for the smaller triangle. So now I've got two things already. And now, what do I do with those? I'm saying, like, all these variables. Another powerful strategy besides drawing lines and labeling them is to add or subtract or multiply or divide equations. Don't try to solve necessarily for the various things. So by subtracting one equation from the other, I know it's hard to see this because we have different slides. By subtracting, in fact, let's go to the previous one. By subtracting equation 2 from equation 1, you'll see that we get, and this is in my book, by the way, in case you want to really go into this. We get this. And it comes out very simply. What I'd like to do is go on to a verbal thing if we can. Let's go on to, let's see if I have a verbal thing. Okay. Let's take a sentence conclusion. This is on the SAT. In spite of her in spite of the dash, and there's you have to fill in the blanks, of her presentation, many people were something with the speaker's concepts and ideas. Now, how would you do something like this? I would probably look at a contrast, something like in spite of. What is the situation with in spite of? What's important about in spite of? It shows a contrast. So that means that the one blank is going to be in contrast to the other blank. Okay? So the strategy is look for contrast or opposition of two thoughts. And then watch for opposition in the choices, right? So the first one, that's not opposite, right? Second one is not opposite. Third one is not opposite. Third one is not opposite. Fourth one is opposite. Okay? And that's the way you do it. By the way, I want to tell you something interesting thing. When you have to test out the choices, if I were on a real time-based exam and I had to test out the choices, and I had, let's say, 2 seconds to do this problem, I'd go from E backwards because the test maker expects you to go down. Now, not that A is wrong all the time, but they expect you to go down when you have to test out the choices. Like which fraction is greater than a half, they'll expect you to go down the string. I usually put the answer toward the end, but I would have gone to E first. And if I would have seen that as an opposite, well, I would have liked to check to see whether the other ones are opposites. But if I'm on a time crunch and I have like 20 seconds to do this, answer this, I would have chosen E once I saw that as an opposite. Let's go to another. Yeah, we did that already. I explained that inextricable, inseparable. Yeah, that's actually, so in, remember not, and extract, extract. Let's look at the writing. Which underlined portion has an error? Until the train stopped at the station, neither the engineer nor the conductor were aware that one of the passengers had become ill. No error. Now, normally, it's been written so that it sounds okay, but it probably is no error. But when you say neither the engineer nor the conductor was, if it were stated the engineer and the conductor, then you'd say were. These people were. John and Mary were. But nor relates to the one person. so it's not were. See that? Let's go to example. Which word should replace the underlined word if the sentence is correct? Dr. Seuss, whose 44 books have sold more than 500 million copies, have made him probably the best-selling children's author in history. Why don't we think about that for a while? I'll give you some time for that. And here's the answer. You see, the Who's 44 books have sold more than 500 million copies. We don't even need that in here. I mean, that's a parenthetical statement. It's sort of like, oh, by the way, this is what happened. What would happen if that were left out? Look at how it would read. Dr. Seuss have made him probably the best-selling author. It should be is probably the best-selling author. You see that? So, you know, it's interesting because grammar is common sense. You don't have to memorize. I mean, in my book, I have a complete set of grammar rules, but I also have ways of doing it with, just by logic. And this would be done with a logical type of thing. So let's figure out. Amith, you said hello, but I'm not sure of what else you wanted to say. I mean, something like it's nice of you to say that. I mean, sometimes somebody will say, "Hey, how you doing?" or something. But but if you want, you can ask a question, of course. But I'm wondering if we should do one or two more, one or two of the. It's too bad I don't have a reading, an actual reading thing here. Let's see if I have another math example. I mean, if you want to write down, you want me to do a math example, you want to do a verbal example, but let's see if I have let's do this one. The average scores of 3 boys was 70. The average scores of 2 girls was 80. What was the average of all 5 boys and girls? You know, if you people have pencils and papers, which I hope you do, because, it'd be good for you to write some of this down, let me know, and, or not let me know, I mean, use it. I mean, we can use it, and, to work on that, because I want to give you some time to think about the problem. I don't want to just, do the problem through this. Okay, so you let's go to the next. Now there are a few strategies that are needed here. First, I label the boys and the girls, A, B, and C, girls, B, and E. Now, remember what the average we have of the boys and girls. We have A plus B plus C over 3. Let's go to the previous slide just to see why we're doing that. You see, the average of the scores of 3 boys was 70. The average scores of 3 girls was 80. So, A plus B plus C over 3 is 70, and B plus E over 2 is 80. And now I say, what do I do? I'm on the test. What do I do? I only have a minute at most to do this question. What do I do? Well, first thing, very important, get rid of the fractions. Okay, so we get that. That's the first thing we do, is get rid of the fractions. Then we get A plus B plus C plus B plus E. Well, then okay, I didn't show that there, but we then add the equations. You can, in two equations, you can add them, subtract them, multiply, or divide them. So we add the equations, and we get a plus b plus c plus d plus d over 5 is equal to that nonsense. All of this is in my books. I mean, all of this are in my books. So you can certainly, I mean, with your own time, you can look at this thing. Okay, let's go on. Let's see if we had another example or something. Oh, this is a good example, this next one. I'm doing typical strategy examples on the SAT or the ACT. If x plus y is 7 and xy is 4, find the value of x squared plus y squared. Note x and y may not be integers. Incidentally, there's such a dumbing down now of tests. The SAT used to have something like not integers, and later on they are integers, and they may go back to not integers. My suggestions to them, but the people are getting dumber and dumber apparently. Not that they are dumb, that they're not learning strategies. So how would you do a thing like this? First thing is, I try to relate, and this is a big thing in math. You want to make connections. Try to relate the x plus y is 7 to the x squared plus y squared, to what you have to find out, or the xy 4 to the x squared plus y squared. But it's a little easy to relate the x plus y equals 7 to the x squared plus y squared. So how do I do that? Well, I see a square in the x squared plus y squared, so why not square x plus y equals 7? Don't be afraid to do this. See, a lot of other things, that people are afraid, students are afraid to take chances. As long as the chance is somewhat legitimate, it's not crazy, I would take the chance. Say square x plus y equals 7. Let's see what I get. I get x plus y squared equals 7 squared. X squared plus y squared plus 2xy is 49. That you should memorize that relationship. You can multiply it out, of course. And now I see that, well, I know what xy is. It's equal to 4. So I just substitute that in there, and lo and behold, I get x squared plus y squared is 41. So let's do a kind of like a summary situation of what's going on here. So how do you do well on the tests? How do you do well on the ACT, the SAT, for that matter, any test? You have to learn basic skills. You have to learn strategies. You can now go one step further and do like what I do. I mean, I may do an extreme thing. I'm going to give you an example of what an extreme thing is. I can go outside, and this has happened, and some people say, well, you're obsessive compulsive, and that's why you're doing this, but I go outside, and I see an address on a door that says 724, let's say. So I say, let me see, if I added the 7 to a 9 and the 4 a 13, and then added the digits in the 13, I get 1 and 3 or 4. The 4 is part of the 724. And then I thought to myself, I wonder how many times that would happen. I mean, if I were in Las Vegas, would I gamble with something like that? How many times could that happen? And then I realized, oh my God, there might be a pattern to that. So I spent 3 hours figuring that out. And it was something like 29%, or I forgot the actual number, but I actually worked it out and figured out what the possibilities were and what that was going on that way. So, and that's why I even have, brain teasers in newspapers. If you ever fly Delta Airlines magazine, every month I have a brain teaser there. And you should see the emails I get. Oh my God, I spent hours and hours doing this thing. Or the flight went by, it's not very positive though, the flight went by very fast because I kept on working on these brain teasers. Some are very easy, some are very difficult. And there's one on my website, in fact, that a geometry question that only 6 people in the nation got right, and that included 2 Nobel Prize winners. So and that's a very difficult. It's what's called the hardest problem that looks the easiest. I mean, it's the easiest, hardest geometry problem. But the more you get, you see, like if you're riding in a car and you see a sign, and you look at that sign and say, gee, if I left that word out of that sign, could I still make sense out of that sign? You know, or if I change the grammar of that, would that be right, or something like that? That's getting involved. This is what I do every day. I mean, that's how I make up questions. You know, uh, get involved in the process, and that internalization will make it so that when you get to the exam, it'll be almost an easy transition. I mean, if I would have to take an SAT exam, it's an easy transition for me. You know, I'm doing all the questions all the time. None of the questions are something where I look and say, oh, I've never seen that before. How could you do that? In fact, if I ever did see that, I'd get really interested, and I'd be more interested in doing the question that way. So you want to get involved, you know, with the situation. That's sort of the ultimate way to practice. Of course, you know, what you really need to do is learn strategies, learn basic skills, and I learned basic skills first, of course, then strategy, and then practice with a question. And I think that's essentially the core element. You know, that's really how you would do well on the exam. You need to take, I can't emphasize this more, you need to take an active approach, though. You can't be passive about it. You have to look at the question and say, what's curious about that question, or what can I extract out of that question? I see a word like desist, and I don't know what the word is, but the D means away from. I'm going to look at it the word that way. I'm going to think of the word being negative. Or if you have a math question and you see that angles are equal, think, well, maybe if the two angles are equal, there also is something else that's symmetrical, or something. And maybe if I draw a line down, which is a key strategy, of course, I'll facilitate the solution. If I draw the line down so it's symmetrical, or it makes something symmetrical, it might even be better. It's these things that you have to, you know, you have to pick up. You know, you want to get more active in your thinking. I mean, there was a song called Save Tonight. I was shocked at this situation. I mean, the situation in the country, in a sense. There was a song, Save Tonight. And the person was with somebody, or the guy and the girl, and he had to leave the girl. He says, I'm sorry, but I have to go, you know, or something like that. And I was, you know, questioning, well, why did he have to leave immediately? Was he going to jail? What was this? And then I saw a blog about this. Maybe 100 people were writing, well, he did it because he was going to jail. He did it because he was this, he was on drugs, and he did it, you know, there were a whole bunch of things. So I got very curious. What does that song mean? Why was I the only one possibly in the world to do this? I wrote to the producer of the song, the one who managed the person, and I said I'd like to find out what that meant. And sure enough, the guy wrote to the guy in Sweden or England, wherever the person was, Eagle Eye Cherry, it was the name. And the guy, he wrote me back saying what he said was that when he was a child, his father used to leave to go to work, and he was a musical artist or something like that, and went to work, and he also was a musical person, and he was leaving the girl to go to a tour that he had to perform with him, and that's why he left. He had to leave. And I found out what it was. And, you know, when I think of it, the tragedy is that with all this blog, with everybody writing, well, I think it means this, why did not one person take the, I don't know, just take it upon themselves to write to the people that wrote the song? And write to, I don't know what that is, whether it's the fear of the rejection or what, but I had to do that. If I see somebody in the street that I think that I know, and I don't want to think for the next 5 days, where do I know them from? I will go to them. My wife hates me when I do this, by the way. She says, you're invading someone's privacy. They don't mind. I mean, I don't say to them, where the hell do I know you from? I don't say it that way. I say, you know, you seem to be very familiar. You look familiar. Do you live around? If you're something like that, and I have to find that out. I am curious, and the thing is, curiosity is what makes you feel young. It makes you feel, oh, you're saying, oh, you're not so young. You don't look so. Look, the fact is that I feel young. And curiosity is a big thing. And if you can, what my point is that if you can get involved on the test and get more curious and get more actively involved, that's the way to do it on these tests. I mean, the fact is that that 90 IQ, I was able to go to 150, and the Washington Post called me the super genius of America because I solved the problem that nobody was able to solve. So I mean, you can go to my website and you'll see a lot of articles about this curiosity. And let me just answer one more question before we close. I meant to answer the question. And it says, I find math very easy. What tips would you give for the reading and writing sections? Because I struggle to get over a 700 on both sections. I want to score above 220, 200 on my SAT, and I'm always falling short. Okay, the reading, again, is to get involved with a passage. Learn the strategies that I have in the books. Those 9, especially the first 3, like the underlining, things like that. And the involvement in the passage is very important. In the writing section, instead of looking at strict grammar rules, I mean, that's nice to know, try to figure the logic. What mathematically will make one thing and the other thing work. Just like what we were doing. A lot of the strategies are in my book. I think in my SAT book, by the way, I have a set of the most important writing questions or something like that. And I think that's, you may want to look at that. I'm always updating the book, so you find new, like in the 215 edition, there's going to be many more updates. But that's essentially what I think I would suggest you do. Well, we're getting close to the end here. Let me Tatiana says, let me see if I can. Yeah, how to do great on college exams. This is essentially what I've been telling a few of the other people. The strategies are very important. That's the key thing. The basic skills you have to know cold. The involvement is very important. Actively involvement. So I think that's that should pretty much sum up what to do on these exams. And I hope this has been useful to you. Please do write me for any questions. I'll try to answer as many as I can. Usually I answer all of them. I don't mind doing this because I like to find out what in fact, many times a student, sometimes I can work with a student and I find that they can mention something to me that gives me a new strategy or gives me something new to put in a book. So, by all means, write me. Let me know, any issues like, I saw this problem. Somebody who sent me a problem once that they couldn't figure out. And I looked at it, and the problem happened to be ambiguous. And I wrote to the College Board about it, and I think the person might have gotten credit for this. But, it was something, I even had I think I reprinted it in my latest edition, in the 2014. I think I reprinted the problem. What do you do in case you get an ambiguous problem? How do you deal with it? If it comes very easily or something like that, and it looks difficult, is that possible? By all means, write me at the. You can write me at the web address. Make sure. Let me just put that on the slide there so that you see that. Or you can write me at Dr. DRGARYGREBER at yahoo.com. But you can also write me at the drgarygoodwin.com. I have an email there too. I do hope to hear from some of you, and it's as usual. It's been a great pleasure talking to you, and I wish you luck on the exam. Oh, one thing I must mention to you. Very important thing. If you're taking the exam for practice, go to the website of the College Board or the ACT and find out what dates those exams are disclosed. Like in the SAT, I believe it's October, January and May. They sometimes can change that, but go to the and the and those tests are disclosed, so you can get, by paying a certain amount, a small amount of money, you can get the exam back, and then you can go over your mistakes. You could look at one of my books and see, oh, I could have used this strategy for that question, or something like that. Very important thing that a lot of counselors don't tell the kids is if you're taking the exam for practice, take the exam on a disclosed date where you get the exam back so you can go over the exam. Very, very important. Uh, so why don't make sure you do that, and the PSAT. In fact, if you take the PSAT, you certainly can get that back. I find that many students don't take advantage of this, and then they'll come to me and they'll say, "I didn't know you could do this," and I have it right in my book. I'm saying it right here. I can't tell. Like stress that enough. But you see, here again, that's an active approach. You need to take an active approach. The more you do this, you'll find in life you will be so much happier, and your life will be so much more meaningful, and you'll appreciate things which you've never dreamt. I mean, I can go to a music concert and get so emotionally involved with this because my mind is actively thinking. I'm actively doing something. And if I look at an exam, I'm actively involved with that exam. So this is very, very critical. I think this is what this nation needs, is to be more active and more interested in what people are doing. So that they'll and it develops self-esteem tremendously, because you can say, oh, I didn't think we could do this, but this is very interesting. I didn't know this could be done this way. So, okay, well, I wish you all a lot of luck. This is not luck. It's, you got to do the work, and you got to learn this stuff. So I really shouldn't say good luck. I don't like when people say good luck, because that means everything's given the chance then. But everybody has potential in them, and this is the critical thing, and you want to use that potential. So with that, I will say, I'll see you next time, and please do write.